Hey guys, let's talk about a voltage amplifier circuit model. Okay, so it's basically has an input side and output side with a gain factor. Okay, so whatever you put here, it will get multiplied and will give you a larger magnitude of voltage on the other side. So the gain factor is called the A, we can see, or V output divided by V input. So this first one figure is open circuit, and the second one is given with a voltage source and a load. Okay, so we can see there's a voltage source here, Vs, and it has a source resistance, and then at the amplifier input it gets Vi, so there's a bit of a loss here, and on the output side it gets amplified by the factor of A, or and then there's the output resistance. So let's talk about those resistance and what are the some of limitations we have here, and what are the things we need to keep in our mind. So we have a input side. So if we apply a voltage divider rule here, if we find out the Vi, we can find out that it's I divided by Ri plus Rs multiplied by voltage source. So a basic voltage divider rule. So one thing to keep in mind that the Ri, the input resistance, this one, the amplifier input resistance, has to be much greater than the source resistance. Why is that? Because if Ri is infinite, suppose Ri is infinite and Ri is infinite, so we get Vi close to the Vs. Sorry, let me zoom in there for a focus. Sorry. Yes, so we will get Vi is close to Vs as much as possible. So while manufacturing the voltage amplifier, the Ri has to be kept very high than the source resistance. All right, we are done here. And at the output side, if we apply a voltage divider rule here, there's a output voltage Vo, and there's a load resistance and an output resistance of the amplifier. So if we apply a voltage divider rule here, we will get the dependent voltage source with the gain factor multiplied by RL divided by RL plus RO. So in this case also, the load resistance has to be kept much greater than the output resistance of the amplifier. Why is that? Because if we keep the RL suppose infinite, so we will get V output will be very close to the input of the voltage source. It will be very close or equal with a amplification factor. Okay, so we don't want to lose any signal. This is why we need to keep RL very higher than the output resistance, and also in the input side we have to keep the input resistance of the amplifier much greater than the source resistance. All right, so and now for the overall gain, like the V output divided by Vs, if we do some calculations, we will get this equation. So V output divided by V input is sorry for some interruptions. If we calculate the overall gain, which means the output voltage and the input source voltage, here V output divided by input source voltage, we get these equations. And remember this RL has to be much greater than this output resistance on the output side, and in the input side the input resistance of the amplifier has to be much greater than the source resistance. All right guys, peace out, have a great day.